All right, so this is question number 5 of the question paper for 2024 November session. So it's a locus question. It's saying that construct a triangle ABC, which BC is equals to 10.5, ABC is 90 degrees, and the angle BCA is 30 degrees. So what we are going to do is that firstly, we are going to put a straight line. We are going to put a straight line, or rather, we are just going to make to put the base angles. All right, that's fine. So I'll take the fact that the angle C is 30 degrees and the angle B is 90 degrees. So in other words, it means that BC is a line which is actually on the base. So if it's a line which is on the base, BC is 10.5 centimeters. So I'm going to start from here. Then I'll take from here up to here, it's 10.5. So 10.5 from here up to here. Then 10.5 centimeters. Then I'm told that the angle B is 90 degrees. So I'm going to construct 90 degrees on the point B. So this is the point. This is the point C. I'm going to take this to be the point C. I'm going to take this to be the point B. So I will construct a perpendicular on this point, which is point B. So I'll come here, then I'll make an arc here, then I'll make another arc here. So where the lines are intersecting with my straight line, I'm going to open the canvas above the radius, then I make an arc here on top, and I make an arc on the bottom. Then I come here, then I make another arc again, then I make another arc. Then I'm going to make them to intersect. So when they intersect, aligning with the point B, it will construct for me a 90 degrees angle. So this is a 90 degrees angle. So in other words, the point A is found somewhere along this line, but I can only be able to know where the point A is when I make 30 degrees angle, which is my angle C. So to construct the angle C, I firstly construct a 60 degrees angle. So to construct a 60 degrees angle, I'll just come here, then I'll make an arc here, then I make another arc which crosses, or I can make a continuous arc. I can make a continuous arc. Then I come here where the line intersects. I'm going to make another arc. So this is the arc here. And I'm going to draw a straight line which makes a 60 degrees angle. A straight line which makes a 60 degrees angle. So this is a 60 degrees angle. But what I want is a 30 degrees angle. So I can bisect. To bisect is to divide into two. I'll simply make a continuous arc here. Then I come here. Then I open. I make an arc here, then I make another one here where the arc is intersecting the other lines. So this is it. So I'm going to join the point of the origin and the intersection of the lines. The point of the origin and the intersection of the lines. So this is it. So what I can say, this is C, this is B, and this is where point A is, and this angle is 30 degrees and this angle is 90 degrees. So I've managed to construct the triangle. So the next point is saying that we should construct the locus of points which are equidistant from AB and AC. Locus of points which are equidistant from AB and AC. So locus of points which are equidistant from A, B, and AC. So that kind of a locus is an angular bisection of this angle. So since it's an angular bisection of this angle, I'm simply going to come here and I bisect this one. So I'll simply do what I did initially when I was bisecting for 30 degrees. So I'll come and stand here. When I stand here, then I will make an arc. When I make an arc, I can stand at this point on the intersection of my arc and the line BA. Then I make another arc. Then I can stand here on the intersection of my other line and make another arc. So wherever these lines are intersecting, which is at this point here, I'm actually going to join. So that angular bisection is the locus of points equidistant from the two lines, which are AB and AC. That's fine. So that is that locus. Then the next, I've got, they're saying that I should construct the locus of points which are 3 centimeters from BC. 3 centimeters from BC. So 3 centimeters from BC. So this is the line BC here. So the locus of points equidistant from that line. Firstly, I can make some circles. Firstly, I have to measure 3 centimeters on the ruler. So these are 3 centimeters on the ruler here. So after that, I'll make some circles which are 3 centimeters. So like this, I make a circle here. Okay. Then I'll come here. Then I make another circle, because I want to construct the lines parallel to BC. But those parallel lines, there will be 3 centimeters from BC. So that's what I'm doing right now. So this is it here. So I will draw the common tangent to my circles. The common tangent to my circles. So this is the tangent here. Alright, that's fine. Then I'll draw another one, another common tangent to my circle. So the common tangent to my circles. So if I measure, I'm actually going to find out that these points are exactly 3 centimeters from BC, but to do it in a way of locus or construction is actually to draw the parallel lines to BC. Alright, so the next point is saying that I should measure and write down the length of AB. Measure and write down the length of AB. Measure and write down the length of AB. So AB is this one, A to B. So to measure and write down that length. If they say measure, they're not saying construct. So it means I'll simply measure like that. So it's actually 5.567. So it's 5.7 centimeters. 7 centimeters. Okay. So there comes the interesting part. They're saying that a point R is inside the triangle nearer to AB than AC. Is inside the triangle nearer to AB than AC. Nearer to AB than AC. It means it's found in this region. It means it's found in this region. Then they say that 3 centimeters from BC is 3 centimeters from BC. Shed the region which R lies. So it's also 3 centimeters from BC. So it's nearer to AB than BC, which means it's this side of our bisector. So it's also 3 centimeters from AB. It means it's not above this line. So they're saying that I should shed the region which R lies. So this is the region which R lies. This region here, this small trapezium, that's the representation of the region R.